Okay, so we're going to get started here. Today's webinar is on fixtures and weldments and 3D printing. Thank you guys for all attending. It's going to be on weldments, fixtures, SolidWorks, and how 3D printing can help. And this should be fun. It's going to take about 45 minutes, and then at the end, we will get started on answering any questions that you have to. So on today's agenda is going to be weldments, some new tricks for 2018. And basically, me and Todd have been using weldments and fixtures for a long time. So we've come up with things that we've learned that may not everyone know. And so we want to share these. I hope it'll be fun for you guys to learn. And Todd is a product manager for SolidWorks. He's been using it for a long time, so he knows all the ins and outs of SolidWorks. And I work in the 3D printing department. And so I know all about how 3D printing can help you with making jigs and fixtures. So that's the lineup today. That's our agenda. So the first question is, what is a welding fixture? What can this do? So a welding fixture just helps you hold two parts together so that you can weld them in the correct orientation. Without this, it would be very difficult. If you've ever done any welding and you put down the hood, you can't see much. You don't know if anything's moving, so you need to hold it together. That's one of the main challenges for welding, is actually holding everything together, not actually welding itself, but holding everything together. So a fixture is just a work holding to hold the parts in their correct orientation. Now, they're not always that easy, so I wanted to show you some examples of some more difficult fixtures. So here's a wooden one for some A-arms for a car that needs to be welded together. That doesn't look too bad, but imagine that. This is some complicated fixtures, and this fixture that they're making, this could be actually really difficult to design. It can be costly, but you need to hold all these tubes in the exact location. Here's another one, and another one. And these are particularly hard round tubes, especially when there's fish mouth and you need to clamp everything together. It can be especially hard and costly to make. So here's some other examples. Okay, so this is where Todd's going to take over. We try to pick something super fun to talk about, and I can't think of anything funner than a shifter cart.
Agreed. I ask you, is there anything funner on the planet? No.
So we're going to switch over and make Todd the presenter.
All right. So we had a great time coming together. Once we figured out what we wanted to make, go-karts have all kinds of welded tube frames. So we thought this is perfect for showing some weldment tricks. And we just decided to go crazy with this here. And so I'm going to focus on this front end here, the front part of the weldment, just to kind of keep things manageable. And we're going to kind of go over some things on how, first of all, how we build up a weldment, just for a little bit of a review. But again, this is not a basics on how to use the weldments in SolidWorks. There's a lot of help out there, especially on our YouTube channel. And don't hesitate to call us if you need help. But I will go through a quick kind of an overview, and then some tips and tricks on locating parts, some self-fixturing, some new features that have come out in 2018 that'll help avoid mistakes. So let's get going with that, and we're going to look at how do weldments work. Okay, let's start here. And okay, so we have, tubes come in a lot of standardized shapes. So we have a library with all of those there, so we don't have to draw any of them based on different standards. We can also draw our own custom extruded shapes that we may have and use those in the same kind of functions here. So you have either a great library ready to go if you use standard stuff, or anything you can draw can be used in these weldment profiles. And it saves a lot of time by allowing you just to sketch some simple lines in a 2D or 3D sketch, the basic framework or the layout of your weldment. And then we can just lay these standard or custom tube cross sections over those lines to quickly build up these frames rather than doing it part by part at the assembly level. So it's just a multi-body single part, which makes sense because weldments are rigid. They tend to not have any moving parts on them. Those usually get added later at a different level of the assembly. So it's a good way to go. There's some great tools for trimming, creating some pretty complex geometry where tubes meet each other. Got a great example of that. And then, we're not limited to tubes. We can put, there's some things for, standard gussets and end caps, as well as allowing you to draw any kind of plate or sheet metal parts as well. That would be in the weldment, all done in the same interface. And you can always get flat patterns for the sheet metal. You can get, cut lists from all the tubes in different sizes, so we know what to buy and how much exactly. There's some, you can put some weld information in there as well, and as I mentioned, the cut list. So let's jump in and see how some of this can help us to get this cart made quickly. All right. So we've got that front frame, and this is just a three-dimensional sketch. And you can kind of see where it's got that angled, this is where that round tube comes up around. But again, it's just lines and arcs, very simple, not a complex sketch at all, especially if you stay 2D. And we just have all our hard critical dimensions in there, so we know our tubes are going to be right where we want them. And once that's done, we just start laying these tube cross sections over those lines. So what does that look like? You mean I have to draw the cross section and tell it to follow that line? No, you just go through your library and you choose your standard. I'm using all off-the-shelf stuff here, standard tube cross sections, and then the type of tube you may want. And then once you've got that, then there's only zillions of sizes that are preloaded. And again, you can create your own if you need, if there's something there that doesn't exist that you need to create. So I've got this 2-inch square tube, 3/16 wall, and I just picked this one line of the sketch, told it to follow that, and that built that square tube. This one's the same, only I just chose a different tube cross section. It's round at 1.5 inch, schedule 40. Keep in mind here, though, the tube is going to follow that line all the way to the end. So we can see here that's interfering with that existing tube. We're going to talk about the trimming and how that gets handled eventually right after this. Okay, then we have just this small little segment of slightly smaller tube, I think 1.25. That runs right through there. Again, running right through the tube. We're going to have to deal with that somehow. And then we built up, again, just creating a couple planes and some simple sketches. We've got these plates for our heel and toe. Okay, so it's looking good. Just create 2D sketches on planes and extrude them. And the weldment functions will keep track of those separate bodies. And you'll see where that comes into play when I make a quick drawing before I head to the metal shop. Okay, so now trimming. How does that work? Okay, in this case, I have the round tube, but I want to trim the round tube against this pink part, the square tube. So I just did a simple cut, and it's just going to find the flat face of the square tube, and it's going to cut off those round tubes right there. And I can fill that with weld, so that makes sense. And I'm left with these two separate bodies. And the good news is the weldment features are going to help me keep track of those two bodies. It's two pieces of the same cross section, but different lengths. Okay, the good part is I don't have to worry about that. All right, and then we've got this other one. Now keep in mind, this one is really tricky. This is a round tube cross section at a compound angle meeting a square tube. So it's two dissimilar profiles meeting each other at two different angles. So this is extremely tricky to figure out what kind of shape is needed there so that those meet. And again, using the trim tool, I'm just trimming the round tube against the pink one. And if I choose simple cut, that's fine. It's just going to use those flat faces. The nice thing about that is I can put a little gap in if I know, my tolerances are a little loose. And so, to get this thing or I need to fill that with weld, I can back up the tube a little bit. What's interesting though, and what leads me to the next example is we can do a coped cut, which is we decide, we need a extremely tight fit here. So when I select that, the weld gap goes away and it does an absolute geometric match against that that square tube to give us that fish mouth cut or that coped cut. Okay, so now I know what I need to do to cut that pipe so that we get a really tight fit when we fixture these up and I weld these. Okay, the trick is, how do I know how to cut it? I mean, I know what needs to be done, but how do I do it? Okay, so this is a fun little trick that we've found recently. A lot of our customers are doing, and we've been seeing it a lot in the industry in general. Okay, I mean, again, there's a really good look at that. How would I know unless I had some, CNC controlled laser tube end cutter? How am I going to do this? Okay, so there's a great little, just using built-in SolidWorks stuff, there's a great little trick that we can do. First thing we need to do is split that face up. All right, so I just split this one cylindrical face at the end. Okay, pro tip here is it can't just be a single line. It does need to have a little gap in there, so just make it extremely small so that it'll be negligible. Okay, and I put the sketch right on center line, and then that'll help me when it comes time when I print this template. It'll help me locate it on the tube correctly. But again, you can split it wherever you feel is the best place. Okay, now that we have the split face, if you have SOLIDWORKS Premium, there's a function built in called Advanced Surface Flattening. And this is for the non-sheet metal type compound surfaces that are extremely hard to figure out the flat pattern for. So that's a couple years old now going on, and it's really helpful in this case. So let's take a look at that. So once I have this face split, then I would just need to ask for that surface flatten. It's on my surfaces command here. I'm just going to pick the face, and then it wants to know a point to kind of tell it where to start unrolling from. Okay, I'm just going to pick that point, and there it is. How would I have ever known that's the shape I would need to draw in order to create a template to grind this tube? Okay, but you see there, it took 2 seconds. I had to add one extra feature, nothing much there. Again, the good news is here, this isn't even a compound surface, so you can see here there's almost no deformation, or stretching or compressing of the surface because it's just unrolling around an axis. So that part's not a worry. And again, handy benefit here is that right from this flattened surface, I can then save that as a DXF. Maybe I have a cutter, or I can plot this or print this. Okay, I'm just going to save this, and then I'll tell it I'd like the 0 to be here on this corner. Oh, whoops. And then this will be the y-axis, that edge. Okay. And then I say go. And there is our pattern. Excuse me. Okay, so now this is what I will wrap around the tube to give me a guideline. This edge here that I could have never figured out on my own is now what I'm going to use to grind against. Maybe I'll just wrap it around the tube and use a marker right there. Maybe I'll glue it onto the tube and just use the edge of the template to grind against. But at least I've got something now. It's a lot more than I had before. And we'll just save that file. So again, a lot of really useful information there with just built-in stuff in SolidWorks. A couple extra steps, and I've got something that's really going to help me out. Okay, I just wanted to pass that on. We're starting to see that used quite a bit. It's really handy. All right. So now let's go down to where we have the rest of the Weldment, and let's look at this new for 2018, this new tab and slot feature. Again, this kind of thing was possible before. There just wasn't a feature for it, so we had to create lots of extra sketches. We had to do these body operations and keep things straight of which body we're cutting into, which body we were extending the tab from. Again, not the end of the world, but that took several steps. but it was a good practice. Since it's a good practice, I'd like to have a feature that just does that for me. Excuse me. And that's what SOLIDWORKS gave us this year. So under Weldments, there's this tab and slot feature. And Luke is talking about fixturing. So we're going to look at this in terms of self-fixturing. So we can create a system here of tabs and slots. We can use that to hold the part in place, maybe with a little bit of assistance on the outside on the table, as opposed to several expensive clamps or tools, something like that. The way this works, again, now that it's not manual, it's just basically a checklist of what I want. And I'm just going to select an edge that I want the tabs to extend from. I'm sorry, I need to hide that part so we can see what's going on in here. Okay, here we are. And there's our edge, and we're going up to this face on the inside of that tube. Okay, need to help it along by picking a kind of a face that sets the direction. Okay, and we can see it. There it is. So it's little tubes, a little tab sticking out there. And now let's look at the controls on how we can get exactly what we want without having to do a lot of extra work. Okay, so I'm going to offset it. You can see these purple and green points. Those are the end points of that edge. So I can offset from there. Okay, so we'll go an inch offset. So we don't want to start right at the end of the edge. And we'll go equal space. I'd like more than one to get a really good hold on there. So let's do maybe 3. So it equally spaces them to the end of the edge. And now I'll go to the offset here, and I maybe want to back off from the other edge. Okay, something like that. We want to get some good grip, so maybe make the tab and the slot closer to an inch. There we go. Got some good grab on there. And we just match the thickness to the plate, which would only make sense. And now there's some options here. We can go up to surface, which is just going to give it, flush on the inside face. That's fine. We can also go blind if we have something else in mind, or an offset from that inside face. If we want to go a little less, a little more. Plenty of options, and all we have to do is click a box. And now, since this is for self-fixturing, depending on your, what kind of tolerances you can hold, I want a really tight fit in there. So I'm only going to put like 15 thou. Okay, so that's that's the offset around the tab that the slot is going to be. So it's going to be a nice tight fit. Give me a little extra hold there for the fixturing. And then we say go. And just like that, you can see we've got now tabs on that plate without me having to sketch anything. We've got slots in the tube, and they're associated to each other. Any changes will be reflected on both. Nice way for a little bit of extra hold there to locate those parts precisely for welding. Okay, self-fixturing, there's maybe a little bit less tooling we have to worry about or buy. All right, here's another use for it. This bracket here, this spindle, it's not symmetric. You can see we've got a smaller hole on the bottom than we do on the top. So obviously it's important which way this part goes on the end of this tube. And rather than creating a very detailed drawing and lots of text explaining, and extra views trying to make it very clear how this goes on, I can just make that impossible in the first place using the same feature. So let's go with tab and slot. So it's going to do, we've got some self-fixturing here. In this case, I'm more just trying to avoid mistakes. So here's what we'll do. We'll put these 2 tabs on here. And we want to go through this face. And I want to help it along by telling it what what face? We're using select other. Okay. And this wall is, all right, I want to maybe just a 1/2 inch slot, and it's the offset here. Okay, we're going to go back to 0 and 0. Oh, and yes, we can't fit 3 on there, obviously. All right, so there's our slot. Okay, and now I'll just offset it from one edge, maybe 3/8 or so. All right, it puts it pretty close to the center. And now since this one is not so much for self-fixturing as more as just to prevent the part going on the wrong way, I'll make it easy to insert, and we can you just got a button there if you want to grind off the, chamfer off the corners, or, with a fillet, something like that, just to make it easier to insert. And again, since it's just more of like a feature to prevent a mistake, not so much self-fixturing, I can loosen up the slot a little bit, maybe, a 32nd in there or something. Okay, so it's gonna be a little looser around that slot, but that's fine. Okay, and it's just like Weldments, where now I've done one group, and now I'm just gonna move on to another group since I'm working on the same parts, and I'll do one here too. Same thing with the edge and the face. And the direction here. All right, and there's our slot. I'll just leave it at that, but now it's coming down that way. So you can see if this were really the case, there is no other way to put this part on except the way the designer intended it to, and that's a good thing. Okay, so you can see we got slots in the bracket now. We've got those little tabs right on the tube. Okay, so I know exactly where to put those. And now when it comes time to lay this thing up on the table and start locking things down, no one can put this part on incorrectly. So that's another really nice use of the tab slot feature. You just kind of make it a puzzle where there's only one way to assemble the parts before welding. Therefore, nobody can get the drain hole on the wrong side, or get a part upside down, because it's just not clear in the drawings. It's just not even possible to do now if you use these features. So again, we just wanted to pass that stuff along. Again, some trends that we're seeing in the industry and with our customers. And lastly, now that I've got my weldment design done, I need to know how much metal to buy. I'll making a quick drawing here. We all know how easy that is. And now with the weldment, let me show you that in the model. Because the weldment's always keeping track of all these cutless bodies. Okay, so it knows their individual bodies. It knows what cross sections they are. So if there's an identical part, it'll group them together, quantity 2 or more. And these separate bodies that are not weldment, but they're sheet metal, again, keeps track of all that thing. It's like a bill of materials. But it's just a single multi-body part. And now in the drawing, I can just ask for a weldment cut list, and I don't have to worry about how long is that round tube. I'd have to measure the straight section and the round section and all that, and where here I can just take care of it. Let the software do it for me. Okay, so you can see with the table here, we've got that square tube, and that's how much I need. That's the finished length after trimming. So I know exactly what I need. It's got the plates and other sheet metal parts in there, as well as the 1.5. So I need that much. And then I may have to do some math here. Here's the 1.25 inch. There's quantity 2. So I could add another column here, and you can do mathematic functions in here to get a total if you want, if the quantity is more than 1 for any one cross section. But again, right there, I'm just letting the software tell me how much tube I need rather than trying to measure it or estimate it, buying too much. Worse, too little. Now I have to go back to the shop. So again, it's just a really nice way to create these kind of models that help you eliminate mistakes and help you get them manufactured. So let's do a quick review here. Okay, so some things hopefully you can use, those welders out there. Again, low volume, could even be high volume, as Luke will explain to you when we start talking about soft fixtures. But there you can see that template that we can print right from the advanced surface flattening, wrap it on the tube. That's what we grind to. Using the tab slot, not only to self-fixture, but to avoid mistakes, avoid putting the parts together wrong and welding them and then scrapping them. And then that cut list is just to be able to have those numbers at your fingertips without having to do all the extra work to come up with those numbers and then still get it wrong. So that's what I wanted to show. And now Luke's got the fun part of like, we got a good design, we've got some tricks to help us get it made. So now let's actually make the thing.
Yeah, thank you. So I'll take over here. Good job. Okay, so you guys should be able to see my screen now. And this is what prompted this. This was a case study that Markforged put out. And with their case study, they had a fixture that was set up to attach two tubes together for welding. And if we look at some of this, the comparison between the Markforged part and the standard process, one of the main things is the fabrication time. To print out this fixture took 11 hours. To outsource this for CNC would take 2 weeks. So it's quite a bit of time saving and also cost saving. So to print this part, it took about $18, where to get this part CNC'd out, it'll cost almost $500. So that makes it almost impossible for a small shop to get something CNC'd out like this if it's a one-time part, or like if you don't weld these same tubes at the same angle all the time, it doesn't make sense to make a fixture. Well, that's where 3D printing can really help. And so we're not always, so of course, in a SolidWorks guy, I went and modeled this, and I thought about it, but you know what? This is a pretty easy example, and this doesn't work too well because it's too easy. I wanted to show you some harder ones. So I'm going to use this example, which is much harder, but I need this exact shape. So I need to build some fixtures that will hold everything in this exact shape and will aid in welding. Like I said, if you've ever done some welding, and as soon as you put the hood down, it's hard to see what you're welding, and it's hard to tell if anything is moved. Your hands are taken up by holding the welder and the rod. So I'm going to make a fixture. The first question is that I'm going to address how to hold these together, what is the most efficient way to accomplish this, and how can 3D printing make this easier, and how much money and time will I save. So I'm going to show you all the details. I'm going to make a simple part or show you how I made it, show you how I uploaded into the printing software called Eiger, and then show you the costs. And then I actually printed the part too, so I'll show you some pictures. So today's part, you have to start with a table or something to put it on. So I found a simple table online. And if we just set the tubes there, it wouldn't stay like this example here. Gravity, of course, all that stuff would fall down on the table. So the goals are how to hold this in the correct location. And so here's my first part that I've made. And this is the one I'm going to show you, this purplish part here. What it's going to do is it's going to hold the two sides, the main tube, the rectangular tube, and the two side sheet metal parts in place. So if I jump over into SolidWorks, here is my part, and how did I make this part? So if I jump over to the assembly and actually show it, this is my part, and if you guys have ever noticed, there's two different icons here that you may have seen. So this one, this is a downloaded part. You see the little hat here? That means this was built with an educational version of SolidWorks. So this wasn't something I built. I purchased a professional one. But anytime someone builds something with an educational, that little stamp will show up. And if you like me, that usually bugs you, so I'd probably remake this. But for this example, it'll have to do. The other one is this part is called part ampersand welding cart. So what I know by just looking at this is I actually made this as a virtual part. This part does not exist does not exist on my hard drive. It exists only within this assembly. And how to do that is you can go Insert, and you say new part, and then it'll be what's called a virtual part that only exists within this assembly. But if I wanted to save it out into a real file, I could right-click on it, and I could say save part, and then it'd become a real part on my hard drive. I could choose where to locate it, and all the relations would still work. Now, if I just edit this part within context, I can roll this back and show you how I made this. So the first thing I did was I made a simple sketch here, and I referenced the holes in the table. So this thing's going to slide into the table. If I go to the inside, you can see it slides all the way to the table. So those are the locating pins that it'll just slide in. And then I just made a simple sketch of how I want to locate this part to this part. So the next sketch is a simple extrusion that goes up, and then a simple cut. So you may wonder why I have these two side cuts on here too. So my build table wasn't big enough. You can see it overhangs some. So what I'm going to do to hold this and lock this in position is I'm actually going to use a zip tie to zip tie this part to my fixture. And I'm not trying to spend a lot of time making these fixtures. I want to show you that it's quick and easy, that you don't have to be a SOLIDWORKS expert to make these. I'm trying to make them as blocky as possible just to get it done, because time is money at a lot of these shops. So I did a simple extrusion cut. So I have 2 extrusions and 1 extrusion cut. I'll do 1 more extrusion to save some material, like that, like so. And the last thing I did was I just added some fill-up. Really simple. I have 1, 2, 3, 4, 5 features. So dead simple. And what this is going to do is, it's actually, if I hide this out of here, I have it's going to locate and reduce the degrees of freedom for this part. So the table is going to, take away 2 degrees of freedom, a rotational and a translation. This side is going to take away another translation and rotation, and this edge here is also going to take away. So by building this fixture, I've reduced all its degrees of freedom. And then with the zip tie, it holds it in place. Once I have this part done, all I did is I could simply mirror this to the other side, and then I have another one done. So I have both sides locating. So now that would hold this part in, and this one in. And gravity, of course, would hold it in with the locating pins. So the other part I made here, and you can get really complicated, but again, I'm trying to keep these as simple as possible. I went to, it's a little bit more challenging. I still made it blocky. So this is the part. I just point out of here. And so this is going to drop into my table again, and this is going to hold the two sheet metal parts at the right location and angle into his top design for this frame. And so we can see that this part here, my 3D printed fixture, is going to hold this sheet metal part and this one. And it will hold it, again, I'm reducing all the degrees of freedom. So it can't move up or down, it can't move left or right, and it can't translate in any direction. It can't move forward or back. So really simple designs for these parts. Now, so the next question I would probably assume you would ask is, okay, Luke, you have this really simple fixture. How do you go about printing it? So I'm going to walk you through that process too. So I have the simple part. All I need to do is do a file, save as, and I'll change this to an FTL. That's the file format for 3D printing. And I've been working with Todd, and so you can see I actually have some revisions of this. If we would have used PDM, that would have been a much smarter way of doing this so that we could have revision control. But so I'm on Rev 3 right now of the side fixture. And when you save up the FTL, always give them a good name and match up your unit. So by looking in the bottom right-hand corner, I can see this little thing that says IPS. That means this part was designed in inches. So that means when I save this out, I also want to save this out as an FTL and use inches. So everything stays the same. Within these options here for the export of an FTL, I'm going to raise the deviation and the angle pretty high here So I have a nice fine part. This example is pretty blocky. It wouldn't really matter, but file size is cheap. I like the most exact part possible, so I'll raise these up. And then I would just save this out. So this is the same as this fixture right here, fixture 3. So you just save out an STL, give it a name, and hit save. So after I have that, here it is on my in my folder. And if we look at these, we can see the different ones that I have made for this example. At first, we started with a round tube, and then we switched to another design. Now on Rev 3. So I want to print this. How I print this with the Markforged printers is you actually use their Eiger software, which is something you guys can all try for free. If you go to our website, you can actually join and download it. Well, you don't even have to download it, it's a login. And so let me pull over the Eiger software. And how this works is first, you would start with your library. You'd start, I have one here for webinars. And you would just simply import your STL. So you browse to it and grab your file. And you hit open, and then it would start uploading it to the cloud. So anyone within your organization that's added to your Eiger account can look at it and they can print it. And what will show up is one of these. So let me grab one of these, and you can quickly copy them for different examples. But so let's put it on a build table. You can rotate it around how you want it orientated. And then on the right-hand side here, all these are really simple drop-down features. So I can choose what material. I'm going to use an Onyx material, which is a mixture of chopped carbon fiber and nylon 6, PA6. So it's a nice, strong material. For this example, since I'm not holding too much weight, I don't need any reinforcement. I'll be printing this on the X Series printers. And there's all these really nice features here. I can adjust my layer height. Right now I'm going to be printing at 0.1 millimeters. And then if we go down here, I can even adjust the fill pattern. So what the heck is a fill pattern? That's how it should fill inside the part. So you don't have to make the part 100% dense. That would actually add time and cost. So my fill density for this example is 20%. And then I have 4 roofs and floors, which are, as you would imagine, the bottom and the top of this part. And then the walls are the sides, and I have two on the sides, 2 walls on each side. And these are the default, except for fill density. Fill density is by default 50. Now it also says recalculate here. So if I raised it up to 50%, it can recalculate. On the left-hand side, what it does is it will give you an estimate for both time and for time, material, and volume. So if I just hit recalculate, it'll recalculate this, and it'll tell me how much time this will cost before I print it, how much material it'll use. It's all really helpful data. It does all the pathing for you. And what's cool is while one thinks, this goes pretty fast, but while it thinks, you can actually go to another one here, and you can work on another one or another whole part. So with this one, the difference is I'm adding reinforcement. I'm adding carbon fiber to this one, and that's why I even labeled it carbon fiber. This one's done, and so I can see that building this fixture costs a whopping $3.24. So it's really cheap to print. Even if this was a fixture for one-time use, $3 to hold your part in, you would probably spend more time than it's worth figuring out any other way. $3 is so cheap. And so the other thing I want to show you is, let's say though, for example, for some reason you need this part to be very, very strong, where you can actually inlay carbon fiber into it. So with this second example, I've inlaid carbon fiber, but you can't really see where it is. So you have no idea what it looks like. There's an option for a view internal. Okay, so when you inlay carbon fiber within your parts, it's going to raise the cost because carbon fiber is more expensive than Onyx. So right now we're at an $8 part by adding in carbon fiber. And what we can see here is on the bottom, this shows you every single layer from first to the last layer. And if I click on it, you can actually see, you can scroll through here and you can see all the different layers. I have a 2D or a 3D view. So if I scroll here, here's layer 1 and what it'll look like. So I can see the supports. I can see how it's going to build the parts. And then as I scroll through, when I get into the carbon fiber, it will show up in this blue color. So that's where it's going to inlay the carbon fiber. And then I'm going to go back to just the onyx material, and then go back to carbon fiber, and then onyx again. And the reason I'm doing this is because I could fill this whole thing up with carbon fiber, but that would just add cost. And if you think about any type of I-beam structure, the majority of the force is on the top and bottom. So you just really want some carbon fiber on the top and bottom. And then you don't need it in the center for most applications. So that's how you can do this. It's really simple. You can click on any one of these and you can see I'm using fiber. It's an isotropic, or you can do a concentric option here. You can adjust the fiber angles. You can create new groups. So let's say I just grab this much here. I could say create a group, and I could say this is a concentric, and I want to reinforce the walls. I want 4 walls if possible, create group, and it'll calculate this. It'll update the time, the cost, the material, and it'll give me a preview of this. So there's my added preview with the concentric. You can see it going around and making that stronger. You can also just drag these and make them smaller or larger. So it's really easy. The software is really intuitive. It takes no time to learn. And that's what I like about it. With the 3D printing software, you don't need this to be some really difficult thing. It just you want to be able to spend as little time here as possible. So you can also revert back to the way it was, but I don't need to print this one. Let's say that I wanted to print this one, the one with just the onyx. The next step would be to just hit print over on the bottom right-hand side. Okay, so now we can see it in the platform. I can see that it'll take 3 hours and 19 minutes to print, but really I need to print 2 of these. So how hard is it to print another one? You just hit add part, and it'll let you browse for every part that you have uploaded to the cloud, or it knows that you already have one of these on the build table. So I could just click on this again, and I'll add 2. Click on it again. So let's just say I wanted to add 5 of them. That's all it takes. And the software is really intuitive. It automatically places them for you. If, let's say, you decide you don't need to print this many, it will reorder as you click them and delete them out. And it's updating the time as we do this too. So then the next thing is, where am I going to send it? So online right now, we have a few printers online that I could send it to. We have a couple Mark X printers. We have one that's busy, that's printing in Redmond, or I could export this to a thumb drive and walk it to a printer that's not connected. And that makes it really simple. So anywhere within the company, I can send a print as long as it's connected to the internet. If I click up here, I can see that there's 4 printers ready, and I can even see that someone's printing right now in Redmond. Another thing that's really nice if you own one of these printers is what's called their dashboard. Well, to finish this off, all I would have to do is hit print and decide where I'm going to print it to. Like if I wanted to print it at the Costa Mesa one, let's change this to the Santa Clara office printer. So Mark X Santa Clara, hit print, and there's actually something printing, so I could say add to queue, and now this one's going to add to the queue for that printer, just like a normal 2D printer. But what I want to show you is also with the software, see this one. So let's say that you don't own a metal printer. Markforged is going to be coming out with a Metal X, which is going to be a metal 3D printer. You could actually choose one of the options here to send it to the metal printer, even if you don't own it, and you can see how long and how much it would cost. So to print this in metal, it would take about 4 hours to print, and it would cost a whopping $10 to print this in metal, which is pretty cool. Okay, there's one other thing I want to show you in this software. So I showed you all the printers but there's this dashboard. So if I go to my accounts and then I go to my dashboard, this is great for accounting and for any justification of buying a new printer or how much material you should order for 2018 or 2019. So right now I can see that we have 8 printers throughout Hawkridge. There's 13 people that have the ability to print. We've printed over 1,000 parts. And it says jobs per week. I can see all the jobs that were sent each week. I can see all the users. I could look at the bandwidth. So if I'm trying to prove to upper management that we need to bring another printer because the printers are at capacity, I can use all this data to help prove my case. And what's really nice is it gives you a way to actually export all this data too. So if you want to add this to a PowerPoint presentation that you need, it's very easy to do so. And this is not something that's usually offered with any other printer, this type of integration. Anything else I want to show you? If I look at any of the printers, this is a Mark X printer. It's ready to print. I can see its temperatures. I could preheat the nozzle. I could send something to it. And I can see previous prints that were done. So that's a Markforged software and a quick little demo. It's really easy to use. It's fast, and it just works. If I go back to my PowerPoint here, so I showed you how to make this part, and then I showed you the software, and this was printed on the Mark X. Printing 2 of them take about 6 hours, costs about $6 to print. And these images were actually just saved out from the software, from the Eiger Software. And then I actually printed these. I was at a trade show yesterday, and at a trade show, I was able to print both these little fixtures. So here's the Mark 7 at a trade show. We can see we have some little giveaways here. So if you came to the trade show, you left with a free little keychain. You can see the final print there. And we can see the parts on the build table. And then lastly, here are the parts printed. So pretty cool. Now, this is what I wanted to show you too. So this is an overkill. You could design something like this that would take a lot of features and a lot of time. You can see the zip ties holding it together. Mine, I purposely tried to make everything really blocky to show you that you don't have to spend this much time. And it doesn't cost that much to make a blocky print. Okay, so I'm almost done here, guys. Next, I'll talk about the Markforged printers themselves. Markforged, Greg Mark started the company back in 2013. He actually used SolidWorks to build the CAD files, and he released it at SolidWorks World. So it's kind of a nice synergy. We use SolidWorks, we sell SolidWorks, we sell the Markforged printers. And one of the reasons why this is so important, these printers, is because it's so much cheaper to 3D print a part and send it out to be machined. So here's some examples of the difference in cost. And why Markforged are such nice printers is because I showed you the software. It's really easy to use the software. You just save out an STL and upload it, and choose your orientation in the material. The printers are very precise, so they hold their orientation. A lot of older printers, they used to warp and change geometry. These ones with that nylon and onyx material with the chopped carbon fiber, they really stay true to geometry. And of course, if you inlay some material in it, like the carbon fiber or nylon, you can have some really strong parts. And they're so successful, you can see their global footprints of where they have sold printers. They've sold printers all over the United States. They've won some awards, some applications. So I don't want to pigeonhole any printer. It's just a tool. So use it however you want. But the one that we have really been talking about is fixtures. And to give you an idea of strength, these plastic and composite printers. So ABS is the typical material used for 3D printing right now. The Onyx material was made to be stronger. So it's stronger than ABS, and it's actually lighter and stiffer. So it's a superior material over printing with ABS and nylon. And then if you inlay one of the other materials like fiberglass, the high temperature, or the carbon fiber, you can get parts even stronger. So here's their base material, again, the Onyx. normal ABS and nylon. Let's say you inlaid some carbon fiber. Look how much stronger it could go. And what's interesting about, pardon me, that's the Kevlar. If you inlay the Kevlar, it doesn't shatter like a carbon fiber part. This part will actually yield out. So you can design with that in mind, and you could design some yield into your part. But if you need a stronger part, you could print it with fiberglass, or you could print it with the carbon fiber. And so the aluminum here is just for reference. Look how close the carbon fiber follows to the aluminum. That's pretty cool to be able to 3D print a part that's near strength of aluminum. And here's a pretty cool example. So this is hard for me to say, Instron challenge. So what they do is they put a bunch of weight on this 3D printed part until it fails, and they can measure the pounds. So they're slowly adding more pounds to this. So they're starting with 2,100 pounds, and you can see it start to flex, and then carbon fiber, being carbon fiber, it fails in a dramatic fashion. But it's pretty cool to see a 3D printed part this strong. Okay, so I'm almost done here. Here's our overall offerings from Markforged, all the way from the hobbyist Onyx 1 to the Metal X, which is a metal printer. The ones that I've been talking about are in the professional series over here, so the Mark 7. The metal one, everyone wants to know about the metal printer. It's coming soon, hopefully in about a month or two. It's going to be the first affordable metal printer. Metal printers usually cost about at least $500,000 for a decent bed size, and then you would need to spend a bunch of money getting your office ready for it because you would need a dedicated room and dedicated power for a metal printer. In some examples of what the metal printer can print, here is the build volume of the metal printer and its layer resolution, its materials. So it's going to start off with some stainless steel being offered, then some aluminums, titanium, some tool steel, and some Inconel. Okay, so I'm almost done here. So some key takeaways from this: the SolidWorks new features, the slots and tabs, and the ability to use those Weldment features to make drawings really easily. You can 3D print the fixtures at a lower cost than CNCing them. You can save you some time. You'll be more accurate. I keep on stressing, as soon as you put down the hood for welding, it's really hard to see what you're welding. So having everything fixtured really tight is, it just makes you feel so much more comfortable when you do any welding. And it's faster than outsourced. So we're just about done here, and then I'll answer some questions. I'm going to let Anthony talk about this. We have some open houses and some open houses and webinars coming up. So let me find.
Thank you, Luke. Are you there?
You here? Yeah. Okay.
Excellent.
Take it away, Anthony.
Thank you, Luke. Thank you, Luke and Todd. Great information. Yes. So we're going to have a few events coming up in March, as you can see on the left side of the screen. The first being in Costa Mesa. We do have an office in Minnesota as well as Redmond and Santa Clara. At these open house events, you'll be able to learn a lot more about this technology, see some of the parts, and we usually have a speaker and we provide lunch. Also, there are a few promotions that Markforged is offering. If you're interested in the Metal X and industrial printer, you can see some of the pricing that's included there, as well as the desktop printer technology with Metal X, which is a great promotion. All you have to do is you pay up front the cost of the desktop series printer, and they include that in your purchase of the Metal X. With that said, if you do have any questions, please feel free to reach out to any of us. My email will be included on the next slide. So if you have any questions, either you can ask them now or you can send me an email or contact me via my phone.
Okay, excellent. And next, I'm just going to go through and answer any of the questions that came up. Thank you guys all for attending. If you have any questions for me, you can email me My name is Luke Davis, or you can email Anthony, or if you just have a general 3D printing sales question, have that too. So I'll just stay online for the next 5 or 10 minutes and just answer any questions. And Todd will be here as well. Okay, so one of the questions that I see here is, how long have you been using the Markforged printers at Hawkers? We've been using them for about 12 months or so. I think we have 8 printers at different offices, and we're always trying to add more printers. And then we have another question here. Does the bottom have to be flat or to attach it to the platform? No, you can actually print any shape. It'll build supports automatically to hold whatever shape you're trying to print. Now, I do like, if I do have a flat edge, I do like to print that flat edge down, or I try to reduce the height of the part in the build volume. So if your part can be orientated so it's only 2 inches tall, it's going to print quite a bit faster than if you orientate it another direction and it's 7 inches tall.
Hey, Luke?
Yes.
One thing I would like to add is that the price difference between the desktop series and industrial series technologies, you have within the desktop series, the Onyx 1, Pro, and 2, and the pricing structure is based on the filament that is added, the secondary filament that's added to the base material. So with the Onyx Desktop Pro, you're going to be able to add in the fiberglass filament. Now, if you step down from there and go to the 1, you're only going to be able to use the base material. And then if you go up from the Pro to the 2, you're going to be able to use all of the secondary fiber filaments. Now, the same is the case for the industrial series printers, which include the X3, the X5, and X7. And those are priced accordingly to the secondary carbon fiber filament. That's it.
Okay, thanks. Thanks for clarifying that. Okay, so we have a question. What is the surface finish of the metal parts? And then can it be adjusted? So the surface finish is, if I go up on the slides here, you can see what's nice about this is when you're done printing it, it's a 98 to 99% dense metal part, meaning you can treat it like any other metal part. You can do tapping, reaming, you can do polishing, heat treating, anything you want. What I would suggest is if you did get one of these, when you're done printing it, you bring it into an automated wash station that you purchase with the printer as well. And you wash away the supports, and then it's in what's called a green state, so it's not fully centered out of the metal. You can lightly sand it there with some 800 grit sandpaper and make it nice and smooth. And then you center it in a centering oven, and then it becomes fully dense. And then sanding is going to be much more challenging because it's going to be a metal part. It's going to be a fully dense metal part. And then I guess another question is, can it be adjusted? You could adjust the infill. So just because the outer shell of your part is going to be metal with the walls and the roofs and the floors, inside you could adjust the cross-section as well. So you can make that sparse or really dense depending if you wanted a lighter part or a heavier part. So that's a cool option. They've even been talking about trying to make a metal part that floats because it would trap so much air inside of it. You would you're going to have a sparse infill and just have maybe even like a titanium outer shell. Okay, guys. Well, I don't see any other questions, so I want to thank everyone that attended and have a great rest of your day.